Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning to everybody. Okay. Thank you, Firza. Yeah, okay. So for today we will continue. Good morning, Amirul. So for today we will continue our discussion regarding chapter 3. I believe everybody have been listens or watching the recorded. It's not a recorded lectures. I mean, it is yeah, it's a lectures that online that we have made before for this course. So for the chapter 3, it's all about the introduction of organic molecules and functional groups. I think everybody have been familiar about this one, and it's just kind of refreshing. Okay, what you have learned during the matriculations, A levels, and also STPM. Okay. So in this topic, okay, we will study about the functional group. Of course, in organic chemistry, they have a huge class of functional groups. And the second one is overview of functional groups, what they have, what bond is involved, hybridization is involved also. So the next physical properties, it's referred as two. Physical properties is boiling point in melting points, okay, and applications. Why a functional group is important to learn about a functional group is all about applications. What's happened if we have vitamin A? Vitamin A is already dissolved in lipids, okay. Meanwhile, vitamin C, it's dissolved in water. That's why if you take too much vitamin C, don't worry too much, because we can discard from our body when we drink a lot of water. But the problem is coming along is the liver and also your kidney have to work hard to remove this one. Okay. And the fourth one is application of solubility. The easiest example is soap, because they have hydrophobics and hydrophilic parts. And also the application of T cell membranes. Anybody who are in from biology schools, you will learn about these ones. Ionic channels, okay, how they allow the ionic elements to enter the channels. And lastly is functional group and reactivities. As we know, anybody who have a more electronegative bonds, it will give different effects, okay, and also the biomolecules like proteins, enzymes, and so on. So, okay. So if you talk about the functional groups with C carbon heteroatoms, they have several functional groups that contain C-like sigma bonds, okay. This means this one is heteroatoms and this one is a carbon, because they have a difference in terms of polarity. So this one is more more electronegative. The electron part is goes to the more electronegative part compared to less electronegative part. Okay. And this is kind of examples of functional group with CZ bonds. Okay. Alkyl halides, we know that's 17 or 7A functional groups, okay, which is include fluorine, chlorine, bromine, and so forth, so iodines. And for alcohols, ROH alcohols, anybody who have OH functional groups, we can call alcohols. Ether is if we change another H with R functional groups, this is what we call ethers. Amine, this is RNH2 amino groups, okay. Thiol with SH, sulfide with S. If we replace thiol, another H with the R functional group, it's become sulfide. Is similar like ethers, okay, but the difference is this one have a heteroatomic oxygens, okay. This one have the sulfur groups. Okay, this one you will see again in chapter, I think chapter 9. Okay, don't forget about these chapters. It's all related. Okay, as I said before, chapter 1 to 6 is more to theories. chapter 7 to 11 is more to the application what you have learned in chapter 1 to 6. Okay, with functional group with C double bond O groups, okay, we have a lot of example of carbonyl groups. Okay, CO bond is a polar bond. Okay, carbonyl is an electrophile. Electrophile, it means this area is willing to accept an nucleophile. The nucleophile or a pair of electrons. Okay, and it also can be acid. Okay, acid Lewis, but because they are interact more to the nucleophile or base Lewis. Okay, this is kind of examples. The aldehydes. The ketone is a carbonyl groups, carboxylic acids, esters, amides. The difference between ester and amide is this functional groups. Okay, and acyl chloride, just replacing this OH functional group with chlorines, or we call acyl halide or acyl bromides. Okay, acyl iodide we don't have that. Okay, we have two bromide and iodide only. But the famous one is chloride because it's for me it's easy to handle. So, we have a lot in our laboratory. In my laboratory we have a lot, more than 10 types. Okay, the importance of functional group. A functional group determine all the following properties. Of course, bonding and shapes is related with the hybridizations also, and also as characters. Type of strengths, intermolecular force, okay. Physical properties, okay. For the naming of the compounds, which is referred as nomenclature. So the chemical reactivities, okay. We have learned before in chapter 2. Also about the chemical reactivities. It means, for example, for alkyne triple bonds, it's the proton which is involved in alkyne is more acidic compared to the alkene and also alkyne. So this is kind of examples, the functional group that we have. This is aromatic rings, okay, amides, because they have carbonyl groups here. So ether, this one is referred as ROR. Okay, amine, they have lots of amine types. They have primary, secondary, or tertiary. Make sure you understand how to differentiate it. Alcohol also, they have also primary, secondary, and tertiary. Okay, these kind of examples. Atenolol is the to treat high blood pressure. Okay, the drugs that they are using. Okay, for another example is these Don puzzles. We have ether here, ether, ROR. Okay, this is ether also. Ketones are, oh no, sorry, yes, R. Okay, of course, this one is aromatic rings. And this is amines. They have a few types of amine, primary, secondary, and tertiary. And lastly, is this one is a aromatic rings. This is kind of examples how you can labels the compound base of the functional groups. In terms of intermolecular force, okay, intermolecular force are interaction exists between the molecules, okay, between two molecules, water and water, they have interactions, okay. So the functional group determine the types of strength of this interaction, of course, okay. And ionic and covalent compound have different intermolecular interactions, okay. So for the ionics, okay, compound is opposite charge, okay, particles together and extremely strong electrostatic interactions. The easiest way is sodium chloride, the salts, table salts that we use every day for cooking, okay. So the interactions because of different charge, okay, it interact very strong compared to covalent bonds. Okay, this means ionic bond is the first one. For the covalent bonds, they have a few types, 3 types of covalent bonds that we will touch later. Okay. Okay, covalent compounds are composed in these 3 molecules. Okay, the nature of force between molecules depend on the functional group. Of course, that's why we learn about the functional group before we learn about intermolecular force. Okay, there are 3 types of intermolecular force: London von der Waals force, or we call London force. This is the weakest one. Okay, weakest one. Okay, so including dipole-dipole interactions. Okay, dipole-dipole interaction, if the compound have a different electron, what we could say, electron deficiency, electron clouds. Okay, it means if the compound have more electronegative compounds, it's probably the particular compounds have a dipole interactions. Okay, the last one is hydrogen bonding. The ability of that particular compound to make the hydrogen bonding. It's not a permanent bonding, it's just kind of interactions. Okay, between water, for example, with that particular molecules, or that particular molecules itself make a hydrogen bonding with their self. Okay. So this is kind of a summary of types of intermolecular force. Okay, as we know, van der Waals is the weakest one. Okay, followed by dipole-dipole interactions, and the last one is a hydrogen bonding. But this one is the covalence. Okay, and this one is the ionic. The easiest way is lithium chloride, sodium chloride. Okay. And for hydrogen bondings, the molecules that have oxygen, nitrogen, sometimes they are using FON. Okay, meanwhile, this one they should have a net dipoles. For example, carbonyls. The net dipole is, this one is more electronegative, this one is more electropositive, so they have a net dipole these directions. Okay, and let's go to the exercise. Okay, I hope everybody have clear about this one. Okay, I think for this one, if we finish by today, tomorrow probably I give you freedoms to do some exercise or study for the chapter 4. Okay. Okay, question 1. Identify the functional group in each molecule. I just take the question from the reference book. It's better to make sure everybody can relate what statement in the textbooks with our exercise. It's better to do that. I can give other than more challenge questions, but for everybody to make sure everybody is familiar with that particular chapter, it's better for me to take from the books. And I also advise everybody to buy and get the book, at least the soft copies. Okay, so for the A, we have this kind of drugs, dark bonds. Okay, so label, identify the functional group. This is the aromatic rings. Okay, aromatic ring. Oh, sorry. Okay, so for this one and this one, and we have this one is ether, ester. Sorry, ester. Okay, and this one is tertiary amine. Okay, this is the first one. Okay, the second one. Okay, we have this one is a primary amine. Nice. Okay, and also this one is the carboxylic acid. Okay, if you are not confident and you can do it like this, carboxylic acid. Okay, you can write like that. Okay. Okay, the lastly is ibuprofen. It's a painkiller. Okay. Everybody have been taking this one. Okay. Unintentionally. Okay, this one is a carboxylic acid. Okay. And this one is aromatic ring. Okay, that's all. Okay, it's easy. Okay, for me it's easy, but take time. Okay, people, what I learned before I meet this class of functional groups. Yeah, you can write amino or amine is okay. It's understanding. Okay, Daya? Okay. Question number 2. Okay. Create. Okay. What types of intermolecular force are exhibited in each compound? Okay, first what we can do is we have to labels intermolecular force, what they want, what types. So you have to mention. Okay, we have three types. Okay, first one is London force. Second one is dipole action. Last one. Okay, so for the B, they have van der Waals, okay, and also Paul, they have only 2. Okay, no hydrogen bonding because this functional group doesn't have any H. Okay, no OH bonds. That's why there are no hydrogen bonding. Okay, for the second one, okay, they have van der Waals. All compounds have van der Waals interaction because this one is the weakest interactions. But you have to check that particular compound whether they have a heteroatoms or a net pole of electrons. So in this case, this one is have a because carbon and also nitrogen have a huge electron poles. So this one they have a dipole interaction. Okay, again, it doesn't have to. There doesn't have any hydrogens because it doesn't have any OH functional groups. And the last one, they have only one van der Waals only. Okay, no dipoles. Okay, because it doesn't have any heteroatoms. Okay. So next, the question is by Israel. Okay, do we need to list all type of force or just the strongest of the compound? No, you have to understand the questions. That explain what types of intermolecular force are exhibited by each compound. Okay, so you have to list all the intermolecular force exists that in that particular compound. So for example, B and C, they have 2. Meanwhile, for the D, they have only 1. Okay, Israel. So next questions. Okay. Which of the following molecule can hydrogen bond with another molecule like itself? Okay. It make hydrogen bonding but with themselves. Okay. It means for the B, which the following molecule can make a hydrogen bond with water. Okay. Okay. Let's make the statements. Okay. Okay. B and D can make hydrogen bonding with another B and D because B and D contain NH and OH respectively. Okay, this is for the question A. Question B, which of the following molecule can make a hydrogen bond to water? Okay, all compound contain, you remember FON, okay, oxygens or nitrogens, okay, they have oxygens here, or I should draw this, okay, okay. So A to D can bond to water. Okay, is it clear? So because, for examples, I just take one, this one. Okay, they have a pair of electrons. They can make reactions with water. Okay, that's why they can make a hydrogen bond with water. It's also related with the solubility of course. It's all about the hydrogen bond formations. Okay, next questions. Okay, Q4. Question number 4. Rank A in C, rank A to C in order of increasing melting point. Okay, so you have to understand, if you see the lecture notes, okay, we can conclude that stronger force give you higher melting. This is the point. Okay, based on the statements, choose wisely. Okay, for this one, for the A, we have Van der Waals. We have dipole directions, and we have the hydrogen bond. Okay. Second one, we have Van der Waals dipole. And the third one, we have only Van der Waals. So as a conclusions, increasing melting point, A, C, B, and A. You have to do like this also. Increasing melting point. Okay. If you are doing like this, okay, for example, yeah, C, B, A, it's wrong. Okay, because of this. Okay, if you do like this and suddenly you draw like this, increasing melting point, so it's wrong also, because the examiner doesn't know which one your answer is. Okay. Question number 5. Predict the water solubility of each of following organic compounds. So you have to predict the water solubility. It means that compound have the ability to make a hydrogen bonding. Bear in mind about this one. Okay. If the compound can make hydrogen bonding, the compound should have the functional group F or N. Okay. So we have mestranol. Okay. They have 2 polar groups. Okay, 1, 2. Possibility can do the hydrogen bondings. Okay, 2 polar groups. But they have but have more than 10 carbons, which is the related with the van der Waals. It's mean it's not soluble in water. Okay, it's similar like cholesterol, right? It's not even though that particular compound have a small fragmented OH in the another side, but the problem is the cholesterol also have the huge more than 10 carbons, so that's why it's not soluble in water, but it's soluble in lipids. Okay. Next example is sucrose. Okay, table sugars that we take every day. So they have so many polar groups: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's a many polar groups. Okay, it's around 11. Okay, so and they have a huge high opportunity to make hydrogen bonding with water. Can we mention about the size of hydrophobic? Yes, I think this one is for the question A, question B, the first one, right? Alistair? Yeah, okay, okay. And this is because they have here many polar groups, it's around 11. It means they have an opportunity to make a hydrogen bond with water. Okay, it's easy. Hydrophobic, yes, you can mention like that. Alistair, don't worry. Okay. But to make sure everybody in the same understanding level of understanding, it's better to use this kind of terms. Okay. So question number 6, explain why A, this is very nice compound, less water soluble than B, even though both compounds have the same functional group. One functional group is involved, one OH functional group, hydroxyl. The second one is aldehyde. Okay. Let's do one by one. Okay. So for compound A, the positions of just label 1 and 2. Okay, the positions of positions of OH and CHO, are close. Close enough. So okay, so can make intramolecular hydrogen molecule. This is the first point. Okay, and the second one, okay, okay, because of two compounds it's involved in intramolecular, so they are less available for hydrogen bonding with water. Okay, that's why A less water soluble. It means, okay, if we try to draw the structures, okay, it's become like this. So yes, okay. Okay. So for the B, we can do the same thing. Positions OH and C. So carbonyl too far apart for intra molecular hydrogen bond. Okay. Leaving both OH and CHO to make hydrogen bond with all. Okay, this is the reason why the A have ability to make intramolecular hydrogen bonds among themselves, okay, and give a less opportunity to make hydrogen bond with water. Okay, so for the B, the functional group has further apart. Okay, this is 1, this is 3. Okay, leave it both functional groups to have a higher possibility to make a hydrogen bond with water. Yes, it's the carbon limits. Okay, check again. As far in lecture notes, they have a carbon limits in water solubilities. Okay, question number 6. Any question? Anybody want to ask about this one? It's quite direct. Okay. Okay. Last question, I guess. Okay. Why cocaine? Anybody who have taken this one, this drug? Cocaine is widely abused, and in Amsterdam they have a lot of cocaine. It's free. Okay, abuse addicting drug. Cocaine is usually obtained as its hydrochloric salt, hydrochloric salt. Okay, cocaine hydrochloride, but can convert it into crack molecules by treatment with base. Okay, question number 1. Which of the compound has higher melting points? Okay. First, what you have to do is you have to compare the intermolecular force. Okay, for this one, this is the ionic. This is the covalent. Only this one is ionic, and so in this in these times they have ionic and covalent bond for cocaine hydrochloride, so it will make this cocaine hydrochloride is higher melting point and higher boiling point. Okay, this one is cocaine. How to explain? They have intermolecular force. This one have the ionic and covalent bonds. Okay. And which one is more water solubles? Okay, as we know, cocaine hydrochloride also have all, including the ionics. So that's why cocaine hydrochloride is also more water solubles. Okay, cocaine chloride. Okay, the easiest example for this to determine the water soluble in this case is like sodium chloride. When you try to dissolve sodium chloride or salt, table salt, into the water, it's easy to dissolve. Okay, and more water soluble actually. Okay, how does the relative solubility explain why crack is usually smoke? Okay. Crack is usually smoke, but cocaine hydrochloride is injected direct to the bloodstream. Okay, for cocaine hydrochloride, why we inject hydrochloride, we inject the bloodstreams? Because salt, we call salt is higher soluble in water. Okay, and it can easily inject to bloodstream. And because when cocaine hydrochloride, or we call salt, we inject to the bloodstream, because bloodstream have a plasma. It can dissolve the cocaine and also transport to the entire body. That's the reasons. The explanations about why crack usually smoke. Okay, so this one, crack. Crack can dissolve in the organic tissues of the cell in this passage. Okay, we heat the cocaine and convert to the gas, and suddenly we sniff it again, take it, the vapors, okay, it can pass through the organic tissues in nasal, in our nose, and also going to the lung, and the lung is processed that particular drugs and can transport directly to our entire body. They have two types of how to take this kind of cocaine. The first one by original neutral form in neutral forms. How we can do that? We just burn it, that particular drug and the spoons, and try to take as a cigarettes. Okay, and for hydrochloric chloride, the crystal. Okay, we usually inject, convert to the liquids, and suddenly we inject to our bloodstreams. And because we have a plasma in our body, it can easily transport to our entire body. That's why when we take the drugs, kita hayal lah, we lalok semua. Okay, so this is kind of education is why they have two types of cocaine. One is neutral forms. Usually we use as a cigarettes. We combine with the tobaccos and we take it. This is what usually they are doing in Amsterdam. And the second one is a cocaine hydrochloride or crystals. Okay, we usually convert a heat spoon and inject to our body streams. Okay, this is what they are usually taking. Okay, but nowadays they have a lot of drugs and crystals, meth, ice. Okay, so okay, boom. Okay, it's finished for today class. Anybody want to ask? Ada siapa nak tanya? 149. Yes, correct. That's right. Okay, I think that's all for today. We have learned a lot about the functional group, solubilities, melting point, and so on, including covalence and also ionic bonds. So I think that's all for today. I guess we will not have class tomorrow, but I need you to sign in the attendance. I will provide you the exercise for chapter 4. Please take time to study chapter 4, and we will discuss on Monday, hopefully. Okay, tomorrow no class, but you have to assign the attendance. I think that's all for today. If you have any questions, I'm happy to answer. There is a lot of questions coming from WhatsApps and also requesting for the one-to-one coachings. So I'm happy to do that, but it's depend on my time. So sorry for the last night. I'm quite tired. I just reply wherever I can. Okay, I think that's all for today. Thank you very much. Stay safe, stay healthy, and I will edit these videos and will put in my YouTube channel. There's another way to do that. Okay, thank you very much. Okay, bye-bye.